channel Class Like Community. So today we will be dealing with the topic RL series circuit. From the topic we can completely understand that R is our what? Resistance. L is our, yes, you are correct. L is our inductance. And we will put the resistance and the inductance together in a single line, which will be our series. So whenever we put the resistance and the inductance in an AC supply, so we will call it as a RL series circuit. Okay, so here this V or this AC supply is an applied voltage and I is the RMS value of the current, or you can say as the voltage has been applied, so one current will be flowing through both resistance and the inductance, right? So first of all let's define the terms which are being used in this circuit. So this V is the applied voltage, I is the RMS value of the current. RMS means root mean square. VR, that is the voltage across the resistance, is our voltage across the resistance is our what? VR, and we can represent VR by IR, right? Because voltage is equal to current into resistance and the unit will be volt. VL, that means the voltage across the inductance will be represented as VL and it can be written as IXL. And now you may be thinking, what is IXL? What is XL? Okay, so XL is our inductive reactance. And XL can also be denoted as omega L. Okay, so today we will be finding some topics with the help of the circuit. First is our impedance. Second is the phase angle. Third is our current. Fourth is our power factor. I have written in short PF. Then we will be finding active power, then reactive power, and at last we will be finding the apparent power. Okay, so for the impedance we need to draw a phasor diagram. So how we will draw a phasor diagram? See, we know that a current will be flowing in both resistance and in inductance, right? So this is our I, and we know that across the resistance the voltage will be similar to the wherever the current will be flowing. That means there will be no angle. But in the VL we know that voltage lead by 90 degree. So this will be our VL, right? This will be our VL, and VL and VR will make our V, that is this applied voltage. Similarly I have made this, okay? So this line will be extended and this is our VR, okay? So this will be a triangle. So for finding impedance we can apply Pythagoras theorem. So what we know that hypotenuse square is equal to base square plus perpendicular square, right? So our hypotenuse is V, so V square, our base is VR, so VR square, and our perpendicular is VL, so it will be VL square. Okay, and we know that we can write VR as IR, so IR square, and instead of VL we can write IXL, so IXL square. So we will remove the square and put a square root, and so we will get, and when we solve this, it is root under I square R square plus I square XL square, and when we take out the I square common and we get R square and XL like this, and when we bring this I outside as square root, then we will get a I and root under R square plus XL square, and when we bring this I down upon the V by I, V by I, we know that it is an impedance, right? So we can write Z is equal to root under R square plus XL square. And we know that XL, that is an inductive reactance, is also known as omega L. So we can also write R square plus omega L square. Now let's find the phase angle. That means this phi. So tan phi, we know that is perpendicular by base. So our perpendicular is VL. So we have written VL and a base is VR. So we know VL is IXL and VR is IR. So I and I gets cut and we are left over with XLR, and we know that XL is omega L. So we can also write omega L by R. So we have completed with the two first topics, that are impedance and phase angle. Now let's move on and find the others. So now we will need to find the current. So we know that I is equal to VZ, because for DC it is R, but for AC it is Z, that is an impedance. So and we know that we have find the impedance and its value is R square plus XL square. So instead of Z we can write this value. So we will get V by root under R square plus XL square, and we know that XL is omega L. So we can also write V by R square plus omega L square. Now let's find the power factor. Power factor means cos phi, and we know that cos means base by hypotenuse. So let's again make our phasor diagram. So this is my I. There will be no angle between VR, and voltage will be leading by 90 degree because it is an inductance, and this will make my V. So it is base, so my base is VR and my hypotenuse is V, so VR by V. So VR we know it is IR and V is a IZ. So I get cuts and we are left with R by Z. So we know that Z is R square plus XL square root. So we can also write R by R square plus XL square, and this XL can also be written as omega L square. Similarly, we can find sin phi. Why we are finding sin phi? Because we will need it in the reactive power. So sin phi, we know that it's perpendicular by hypotenuse. So our perpendicular is VL. So we have written VL. H is a hypotenuse, so it is V. And we know that VL is IXL and V is IZ. So I gets cut and we are left over with XL by Z. And we know that XL is omega L, and Z we can also write as R square XL square, and this XL can also be written as omega L square. Now see, active power means P is equal to VI cos phi, because active power is denoted by P. So VI is written as VI and cos phi we have already found, so it is R by Z, and when we bring this Z by the V, so it is V by Z, that means it is I. So it is, we can write active power as P is equal to I square R, and its unit is okay. Now let's move on and see our next two power, that is reactive power. It is denoted by Q and it is VI sin phi. I already told we will need this sin phi in the reactive power, so we will keep the VI like VI. And we have already found sin phi, so it is XL by Z. So we will write XL by Z and we will bring the X upon the V. So it is VZ, V by Z, IXL, and we know that V by Z is I. So I square XL. We can also write this as I square omega L, because XL is also omega L, and we know that its unit is watt, that means volt, ampere, reactive. And the last, that is the seventh point, is the apparent power. So S equal to VI, that means apparent power is denoted by S, and we know that V can also be written as I dot Z. So we are left with the apparent power, that is S equal to I square Z, and its unit is VA, and VA means volt, ampere. So, today's lecture ends here. If you understood the RL series circuit, till then be happy and have a great day.
Now is the code time. Knowing is not enough. You must apply. I hope all of you understood the lecture of today, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live Magus videos for exam preparation in an hour. We start at class-like community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.